Good morning, good afternoon. And the idea today is to talk about JDK 14. And JDK 14 is really quite impressive because, as the title suggests, we have lots of new features in this version of Java. Now, before we get started on the features that are included, I wanted to just kind of recap a little bit on how we've got to where we are now, because JDK 14 is quite a big number in terms of releases, and we have seen a very rapid change over the last 2 years. Because of JDK 9, the decision was made that we would switch to a new release cadence for the JDK itself. And the decision was made that we would now have 2 releases every year, therefore 1 every 6 months. March and September, we get a new JDK. The great news is that if you look back over the last couple of years, 2018, we got JDK 10, we got JDK 11, 2019, last year, we got JDK 12, and we got JDK 13 very logically. And just last week, we got JDK 14. And this is really good because it means that the process is working very well. And I have to hand it to Oracle in terms of the work that they've done behind the scenes to make this practical. One of the big things that needed to be done was to change the way that the Java community process worked and to be able to get through the specifications for each JDK through that process more quickly. In the past, we've been used to anywhere from a little bit over 2 years to over 4 years between releases of Java. So the idea of being able to do them every 6 months and still have the specification produced and tested and so on is really a great thing to show that this process does actually work. Now, the reason for doing this was that the OpenJDK developers wanted to take a more agile approach to delivering features in the JDK itself. If you look at the way that software is being developed nowadays, we've moved away from the old waterfall approach where we did all of our requirements capture in one part, then we did all of our analysis, then we did all of our design, then we did all of our coding. Now we use a very iterative kind of approach where we can react more quickly to changes in requirements, we can react more quickly to what people actually want from the software we're developing. And by using things like agile methodologies, using the ideas of continuous integration, continuous deployment, it allows us to get the features to our users much more quickly. And really that's the idea for the JDK, getting the features out to the users as quickly as possible. Now, to do that, we've had to see a change in the approach to how features get added to the JDK itself. In the past, the features have very much driven the release. Now it's the other way around, which is that the release drives the features. And what I mean by that is that, again, if you look at JDK 9 as an example, one of the big things there was modularity. And in order for JDK 9 to be released, modularity had to be finished. There were a number of discussions and some feedback about the approach to modularity that required the JDK developers to go back and make some changes, and those changes resulted in JDK 9 being delayed on 2 occasions. If we use the same approach for a 6-month release cycle, then that's not really going to work, because the moment you start delaying anything, you're almost going to be bumping into the next release. So the idea now is that we have a twice yearly release cadence, and whenever a release is scheduled, all the features that are complete and ready to go at that time get put into the JDK. Anything that's not quite ready gets delayed until a later release. And because we only have 6 months to wait, it's not a big deal. It's not like we have to wait 2 or 3 years before we can get a feature in. So all this is working very, very well. Now, the next thing I want to just highlight as well is how this new release cadence has enabled the developers of Java to provide a different approach to how features are added. In the past, as I said, feature-driven releases, that feature had to be defined, it had to be finished, and that was then put in and set in stone. What we've seen now that we have this faster release cadence is that we can add features in a way that enables them to be tested by users, by developers, and then feedback can be gathered, and then if changes need to be made, they can be implemented before it becomes part of the standard. And we're doing that through what we call incubator modules and preview features. And the thing is that if a feature is deemed that it's not quite right, as I say, we can make changes. And in an extreme case, the feature could even be removed completely because the decision is made that actually it doesn't really work, it doesn't do what it's needed to do, so let's just take it out completely. And in terms of those two things, incubator modules are defined through JDK Enhancement Proposal 11, and these are things which relate to either API changes or tool changes. If we look at an example of that, the first one was in JDK 9. That was when support for HTTP2 was introduced, and that was made an incubator module, went through a couple of iterations, people looked at it, gave some feedback, and then it became part of the standard, I think, in JDK 11. Then we have the idea of preview features, and these are defined through JEP 12, and these refer to either language changes or VM changes. First example of that was in JDK 12, where we got the idea of a switch expression. And we'll come back and talk a little bit about switch expressions later on. But this was a very good example of how powerful this way of developing things is, because feedback was given after the JDK 12 was released. Some changes were made in JDK 13, which allowed it to be modified in a way that suited developers without having to go back and change the specification and go through all the complexity of doing that. So preview features, incubator modules, very, very useful, very powerful way of developing the platform. Okay, JDK 14. Now, JDK 14 is a very exciting release because it has a lot of big developer features. And this is not because there was a lot of things that happened in the last 6 months. Because we have this new faster release cadence, actually you get points like JDK 14 where a number of things all come together at the same time. So some of these things have been in development for a while, but now they're all ready at the same time. And so JDK 14 is this kind of exciting release of the Java platform. 3 specific things from a language level. First is records. This is a preview feature, so we're going to be looking at it. We'll see what it does, and people will still be able to provide feedback, and possibly changes can be made. Second thing is pattern matching for the instance of operator. Again, it's a preview, so we'll look at that, see what that does. And third one is text blocks, which were introduced in JDK 13 as a preview feature. This is now a second preview of that. So changes were made, but there's still the chance to change it further in the future. From an API perspective, a lot of the API changes relate to the new record functionality, but there's also some other interesting things like foreign memory access API. Again, that's an incubator module, meaning that we can look at that and see whether possibly changes need to be made before it's part of the standard. Okay, let's look at records. Now, Java is an object-oriented language, and that's all very good. It's very powerful. We have the ideas of encapsulation and things like that. If I want to create a class in which I want to put some data, I need to do something like this. So I've created a class which is a point. 2-dimensional point has 2 values, double X and double Y. And in order to define that, using standard Java syntax, I create myself a class, I put 2 instance variables, I make them private within the point class, I make them final so that they can't be mutated. Then I need a constructor. The constructor needs to take 2 arguments, which is X and Y. I assign those to my instance variables, and I've got 2 methods, which are the accessor methods for the X and the Y values. All very good, very logical. I can look at that, I can understand exactly what's going on. The drawback is that just to have a class that holds 2 double values requires me to write 14 lines of code. So it is very verbose, and in this simple example, it's just too much for what we want to do. Records is all about changing that. So if we look at using a record to do that, now we can say record rather than class, point, and here we then define the set of component fields that we want for this record. That's going to be our double X and our double Y. Now the syntax says that we then need a set of braces to define the body of that record, but in this case we're not doing anything, so we leave them empty. What we're getting here is a data object that stores these 2 values and does effectively the same thing as our 14 lines of code on the previous slide. But some important things about this. One, a record is not a class. So what's not happening here is simply syntactic sugar to say, take that definition and expand it out into the equivalent class that we had on the previous slide. A record is like a class, but it's not exactly a class. You can think of it like the way that an enumeration has been designed. So an enumeration, again, is like a class, but is distinct from a class in the way that it behaves. Same thing with a record. Now, there can be situations where we might want to do a little bit more than simply define the component fields that we need in our record. And we can do that. So let's look at a second example here, where what we're saying is that we want to have a record, which in this case is going to be called range, and it's going to have two values again, low and high. But this time, the important thing is that we want to be able to test when we call the constructor whether the values conform to the design of our data object. In this case, we want to make sure that high is in fact greater than low. And so what we can do is we can say, right, define the record, but now we'll provide an implementation of the constructor. So we have public range. We don't need to specify the arguments of the constructor because that's already specified in the fact that the range has these component fields low and high. But then we can put some code in there to do the necessary testing. So we say if low is greater than high, then we'll throw a new illegal argument exception saying it's bad values. Important thing here, when we want to do something like this, we can throw an unchecked exception. That will work quite happily. So illegal argument exception is unchecked. We can throw that without any problem. What we can't do is throw a checked exception. So we couldn't have some way of saying public range throws my checked exception. That won't work. So it's only unchecked exceptions that can be thrown from the constructor. Now, that is a restriction, but that's the way it's been designed. If you look at the AMBER mailing list, there's some discussion about how that works, but the decision has been made. That's the way it is going to work. Other things we can do is we can override the standard methods that you get in an object class. So equals hashcode and toString. If you want to provide an alternative implementation of those, then you can. Here I've overridden the toString method to return the string that I want. If you don't provide implementations, then they will be derived for you from the component fields that are specified in the way that the record is defined. Instance of. So instance of is an operator that's been around since the beginning of Java. And what it allows us to do is to test the type of an object. There are many situations where you may get a reference to an object, but you don't know exactly what type it is. And you can use instance of to test that and then do something relevant. If we look at the simple code example here, what we're saying is if obj is an instance of string, then we want to use it as a string. The only way we can do that, though, is by explicitly assigning the object to a string reference and doing an explicit cast. So we have string s equals string obj. Then we can use s and we can call the relevant methods on that. Now, again, that's a little bit of verbosity. It's a little bit less ideal because we have to make this explicit cast. The idea behind pattern matching in what we're doing here is that we can change that. So now what we can do is we can say if obj instance of string, but we can then also specify a variable which will be used if obj is an instance of string. And then the scoping of the s variable will apply to where that makes sense. And this is quite important. So in this case, we have an if statement, and if that predicate equates to true and the object is a string type string, then within the body of that if statement there, we can use s and the scope is valid because clearly it is a string, so we can call s.length. However, if we look at the else branch of that if statement, because that would be the false part of the test, obj isn't an instance of string, then s doesn't make any sense there. So we can't use s, the scope is not valid, so we can't call anything on that variable. Now we can take that a little bit further because what we could do is something like this. So we can say if obj instance of string s and s.length is greater than 0, then print out the length. Now that will work with scoping, because in the case of an AND operator, we have to evaluate the left-hand side first, but we will only evaluate the right-hand side of the AND operator if the left-hand side is true. So long as obj is an instance of string, then S becomes valid in terms of scope, and therefore we can use it on the right-hand side of the AND operator, call the length method on it, do the test, and then the if statement works. If, however, we were to use an OR operator, that wouldn't work. So we get a compiler error if we said if obj instance of string S or s.length is greater than 0, because in that case we have to evaluate both sides of the OR operator in order to determine whether it's true or not. We could evaluate obj instance of string S, and that could be true, in which case that would work. But even if it wasn't a string, we'd still have to try and evaluate the right-hand side and say s.length greater than 0. But because obj is not a string, we can't call the length method on S, and it doesn't work. So we get a compiler error in that case because it doesn't make any sense. Now we can take that a little bit further, and we could do something like this. So we could say if, and we test O instance of string S, but we say if that's not true, then we'll return. So we haven't got a string, we'll return from this method. After that test, obviously, S would still be valid as a string, because the true test would actually allow us to go past that statement. So we could then, after that, print out s.length because S is still valid, it's in scope, and it would work. Now, this is something which some people have been a little bit less than enthusiastic about, shall we say, because the way that the scoping works, it's not always immediately obvious. And some people have criticized, especially this particular point where scoping works so that you can still use S even though you're past the if statement. Personally, I think this is fine because in terms of the way that it works, it's all completely logical. There's nothing there that you can point out and go, well, that doesn't really make any sense. In this case, it all works very nicely. You know that if you've got past that statement, it is O is a string, therefore you can reference S and it will all work quite happily. Text blocks. Text blocks were introduced in JDK 13. And they were introduced with the idea of enabling you to specify a string, which could potentially include new lines, but basically could contain anything that you wanted and go across multiple lines and make it easier to define strings within Java. In the past, we're all used to defining strings being delimited by a single set of double quotes. With text blocks, as they were introduced in JDK 13, we now have the idea of delineating a string with 3 double quotes. And by doing that, anything that goes after the first opening 3 double quotes will be treated as part of the string up until the next closing 3 double quotes. Obviously, if you want to put 3 double quotes in your string, you can escape the first one at least, and that will work. So that was all fine. What they've done in terms of the second preview is not really change it very much. They've added literally 2 new escape sequences. First of those is just a backslash. So in this case, what we're going to do is we're going to say we have a continuous string, and we will start that with 3 double quotes, run the line, and then we'll end that line with a backslash so that it continues onto the next line. This is very common in other computer science type things. If you've done shell programming, you'll be familiar with this. It's very common. Make files as well use this sort of syntax. So all it means is that you continue onto the line. You don't put a new line in between. And so if you've got a very long line, but you still want it to be a single line, you can do that and break it up with backslashes. The second escape sequence that's been added is \s. And \s represents a space, so that in order to be able to maintain alignment of spaces, this is a good example here, where if when the text block is processed by the compiler, it needs to evaluate the idea of incidental white space. Incidental white space is on the left-hand side of the text, so that you can line up red, green, and blue, but you don't necessarily want the indentation for green and blue, you want them to be lined up with red and green. So that's the way that incidental white space works. But in order to have that processed, the compiler will strip out white space from the front of the strings as well as the end of the strings. If you do want spaces at the end of the strings, then you can mark that by saying, okay, put some spaces and then put a \s to indicate a single space, and then that will line everything up and it will all work the way you want it to. Small change, but just kind of addresses some considerations that people had in terms of this feature. Switch expression. As I mentioned, this was the first preview feature that was added to the Java language, and essentially that was in JDK 12. In JDK 13, a small change was made because people provided feedback around the use of the break operator and said that they didn't like the overloading of break, so that you had break with a value to indicate what would be returned from the switch expression if you were using the older style of syntax with multiple case statements. In JDK 13, they decided rather than using break with a value, they would change that to yield with a value, so that you wouldn't get confusion between break with a label and break with a value. Small change, but again, addressing concerns that have been raised by people who used it. Now that this is part of the standard, so it's been included and no more changes, you don't need to use the enable preview flag to use that particular feature. Any other preview features, such as text blocks and records and so on, you still need to specify the enable preview flag, both with compilation and with runtime, in order to enable those things. Helpful null pointer exception. This is my favorite feature in JDK 14. Now, anybody who's written more than probably about 10 lines of Java code is going to have some point created a null pointer exception in their code. And this is a result of referencing something through a pointer to an object which hasn't been initialized. So it's been initialized to null, so it points at nothing. You try and reference either a value through it or a method through it, and the compiler and the JVM will say, oh, no, that's not going to work. It isn't a valid value, therefore you get a null pointer exception. Now that's fine, but we often run into a situation like this, where we've said, we're going to use A, then we're going to reference B from that, then we're going to reference C from that, and then we're going to reference I from that and assign 99 to it. That's all well and good, great Java code. Except that if we get a null pointer, we may get something like this. So we get exception in thread main, null pointer exception, and we are told that it's on line 5 of our Java program. Well, that's great, because now I know which line of the code I need to look at. But I look at this and I say, well, what's the problem? Was it A that was null? Was it B that was null, so I couldn't reference C? Or was it C that was null, so I couldn't reference I? What actually was the problem? And in JDK 14, we finally have an answer to that problem. Now what we get is exception in thread main, null pointer exception, cannot read field C because A.B is null. Brilliant. Now we look at that piece of code, we immediately say, aha, A.B is null. Therefore, I need to go and find out where did I think I'd assigned B in the A.B piece of that code, and then I can trace the bug much more easily. Now I don't need to use the IDE, I don't need to fire up my debugger, I don't need to start splitting this line up into multiple lines and doing printouts of, what is the value of A, what is the value of B, what is the value of C, and all those sorts of things. So now, like I said, this is a great new feature to make developers' lives easier. The only thing I would say is, how come it's taken us 25 years to get to this point where we have a helpful null pointer exception? Imagine the amount of time that we could have saved in terms of development if we'd had this from JDK 1.0. Not a criticism at all, just an observation. Other features that have been included into JDK 14. These are things which are not language changes, but not API changes. And we've got a set of JEPS here. These are JDK enhancement proposals. First of those is a packaging tool. And again, this is an incubator, so it's something that will change potentially over time. And if you look back at JDK 11, the Oracle JDK used to have the JavaFX libraries in it. Part of that was a packaging tool that people really liked for creating deployable packages of an application. That was removed from the Oracle JDK in JDK 11. And so to address that need, the packaging tool has now been introduced in JDK 14 as a way of doing that. Next JEP is 345. That's the non-uniform memory architecture aware memory allocator for G1. And the idea behind this is to enable for machines that have a very large amount of memory and use NUMA as a way of managing that, so that you get better memory allocation and better performance on those types of machines. Next thing is for Java Flight Recorder. And if you look at the way that works, Java Flight Recorder is a way of collecting information about the things that are happening within the JVM that are performance critical for your application. So things like garbage collection, thread synchronization, method calls, and so on. And it allows you to collect those events and then either look at them on a running JVM, or you can collect them into a file and then post-process them in a sort of after a crash or after your application stopped. The drawback in the past has been that the records have all had to be sort of bundled up into packages, like into records, and then made available through that. With streaming events, now each individual event is available as it's created, so you can look at a much more kind of real-time set of events that are generated from the VM and give you the ability to look at what's happening with your application in a better way. 352 is non-volatile mapped byte buffers. This is kind of related to some work that Intel have been doing around non-volatile RAM and having it perform at the same speed as dynamic RAM. We had that included for heap space allocation back in, I think, JDK 12, and now we've also got that applying to mapped byte buffers. Last thing here is two JEPs, 364 and 365, which are related to the ZGC, or as Americans like to say, ZGC, which is a low latency experimental garbage collector. That used to be only available on Linux. Now with these two JEPs, there are versions available for Windows and for Mac. Deprecation and removal JEPs. So since JDK 9, it hasn't just been about adding features to Java. It's also about having a bit of a cleanup and removing some of the features which, because they've been around for a very long time, are no longer used by, well, either anybody at all or a very, very small number of users. First of those is the removal of the CMS collector. And this was deprecated back in JDK 9, so it's taken a little while to get through to this point, which is fair enough. But CMS has been superseded by G1. G1 uses some similar algorithms, but because it divides the heap space into regions, it's much more efficient in terms of the way that it can reclaim space as the garbage collector works. Oracle had made the decision. They said, well, CMS is quite like G1. G1 is better as a collector. We don't want to have the overhead of trying to maintain two similar collectors, so we'd rather just focus on G1. Some people have said, well, there are situations where CMS works better than G1, which that may be the case, but the problem is that maintaining two collectors is a lot of work. And Oracle very fairly said, well, okay, if somebody wants to step up and continue to maintain CMS, then we're quite happy for that to happen within the OpenJDK project. Nobody did, nobody put their hand up, so it has been removed from JDK 14. Similarly, in terms of the Solaris and the Spark ports, Oracle's product direction has moved away from both the Solaris operating system and the Spark architecture, which they got when they acquired Sun Microsystems, well, 10 years ago. Can you believe that? So they've decided that they no longer want to support that. There is a chance that that may be picked up by people in the community, so there is still some discussion around that. Similarly, deprecating the parallel scavenge and serial old garbage collection combination. It's a kind of weird combination of garbage collection flags. So again, trying to maintain that doesn't really make a lot of sense. So it's been deprecated. It will probably be removed at some point in the future. Last one here is removal of the PAC 200 tools and API. This is related to the idea of primarily the applet support. So PAC200 is a compression technology that was used for jar files for applets. It was deprecated back in, I think it was JDK 11, and so now it's been removed completely from the JDK. So applets really are very much dead in terms of Java now. API changes. I went through all of the changes to the APIs, and there are about I think there were 69 API elements that got changed. Let's have a look at what we got there. So first of those, as I mentioned earlier, is what's called the Foreign Memory Access API. And the idea behind this is that if you think about the way Java works, we have the idea of objects and we have references to those, but we use implicit pointers rather than explicit pointers. We have an object reference, we can't manipulate it in terms of its address. Unlike in C and C++, where a pointer is simply a number and we can mathematically add or subtract from that, we can't do that with object references in Java. Now, in some situations, people want to have memory which is allocated off heap. And to do that, they've used things like mapped byte buffers, or they've used some of the low-level features in Sun-MISC Unsafe, which is a unsupported API. It's part of the internal APIs of Java, never supposed to be used by developers. The Foreign Memory Access API is designed as an alternative way of doing these things, but using a well-defined API that is supported. What you get are three different things. You get a memory segment, a memory address, and a memory layout. Memory segment is essentially the area of memory that you want to gain access to. So you assign the area of memory to a memory segment. Then you use a memory address to index into that to get the information, either read or write the information that you want within that memory segment. So it's effectively like a pointer, but you do it through an object so that it's not as explicit as just using a number. And then a memory layout is applied to a memory segment so that you can tell the library code how you want that memory segment to be organized. For example, you could say, okay, I'm going to be storing ints in this memory segment, or I'm going to be storing longs in this memory segment. That then enables the memory address class to be used so that it can figure out for you where the next piece of data is in your memory segment. So if you're sort of striding through the data in your memory segment, if it's ints, obviously you're incrementing the size of the real pointer by 4 bytes. If it's longs, you're incrementing it by 8 bytes. By specifying the memory layout, the memory address knows how to do that correctly, and you don't have to do it within your code. There are quite a lot of APIs related to the new record functionality. Like I say, records are not classes explicitly, so they're like classes, but they're not classes, and therefore they have a number of APIs that are related to that. One thing that's interesting here is that all the APIs which are related to preview features are immediately deprecated. And that makes a lot of sense, because if you're going to change a feature in the next release, or you're potentially going to even remove it completely, then any APIs that relate to that need to be either changeable or removable at any time, because if you decide to remove that feature, you also want to remove the supporting APIs along with it. So they are immediately deprecated, but potentially if that feature becomes standard, then the deprecation can be removed and they're undeprecated or de-deprecated or precated. In terms of the APIs that we've got here, class now has 2 new methods: isRecord to tell you whether it is a record that you're dealing with, and if it is, then you can get a set of record components which give you information about that record and what it has in it. There is a record class, so Java-lang record, which is used to represent a record. And then you also have the idea of an element type for annotations, because if you're going to apply an annotation to something, then you want to be able to specify whether it's a class, whether it's a method, whether it's a record, and so on. So that's been updated to include records as well. Java-lang runtime is a new package. I was a bit surprised. I thought that was already an existing package, but no, it is a new one. And that contains a single class called object methods, and that class has a single method called bootstrap. What that will do is it will generate a set of methods that are required for a record, and those are essentially the three methods that you have in an object: equals, hashcode, and toString, which you need for a record. And then the javax.lang.mode.util package has some new classes which includes some additional things around records. This is quite a low-level package. It gets updated when the language gets updated. So the new classes in here all end in 14 to indicate that they're from JDK 14. Serial annotation. This is used for enabling compiler checks on classes which implement the serializable interface. And it's similar to the idea of the override annotation, where you want the compiler to be able to check that if you think you've overridden a method from a superclass, then you've done it correctly. If you haven't specified the method signature quite correctly, then the compiler can notice and say, oh, hang on, this doesn't actually override anything in any of the superclasses, therefore it isn't quite what you think it is. And then you can go back and check. Same thing with this is the idea of being able to annotate any of these methods, write object, read object, and so on. Or if you're using the fields serial persistent fields or serial version UID, you can put the serial annotation on that and have the compiler do the checks for you on those things. A few miscellaneous API changes. The NullPointerException, this now overrides the getMessage method from throwable, because we're getting a more useful message that's handled through the NullPointerException, and it has to override getMessage in order to be able to do that. Strict math now has some new methods which are part of the exact way of doing things. There's increment exact, decrement exact, and negate exact. This is to do with if you're using certain values and you want to handle the idea of overflow. So if you increment something and it overflows, or if you decrement something and it overflows, then that's handled in a different way. So that's part of the strict math class. Compact number format has a new method called plural rules, and this relates to some ISO ways of describing numbers using names, and so plurality is defined through that. There's different ways of doing that, and so there's a new method of defining that. And then finally, hashset has a method called toArray, which, funnily enough, provides an array of the values in your hash set. Okay, just briefly mention at the end here what we do with Zulu Java. So we provide a build of OpenJDK. We have two versions of this. One is called Zulu Community, and this is where we take the OpenJDK source code from the repository and we build it, run all the build scripts on it, generate a binary distribution, and then we run all the TCK tests on that. It's about 150,000, which verify that what we've produced actually conforms to the Java SE specification as defined. Very important thing here, it is free. So you can just go to our website, you can download it, use GPL v2 with class path exception license, same as the OpenJDK itself. So no restrictions on where you can use that. And I may have mentioned it is also free. In terms of version support, we actually provide everything from JDK 6 all the way through JDK 14. And we do currently have a JDK 15 available as early access. It's not very much different between that and 14 at the moment, but as development continues, that will be updated, so you can try that out as well. So lots of different versions supported there. We also have nice wide platform support. We've got the usual Intel 64-bit, Windows, Mac, and Linux versions. We have 32-bit versions of Intel for both Windows and Linux. If you're using something like Windows XP still, then you can do that. And we also have ARM32, ARM 64-bit. If you want to run it on your Raspberry Pi, you can. I did that yesterday myself. And even we have PowerPC 32 and 64-bit and Solaris 10 and 11 versions on Spark. So pretty much, you know, most of the things you might want. Okay, we don't have AIX, we don't have a few other things, but very wide support. All those available, downloadable from our website here. If you want commercial support for OpenJDK and you want to make sure that you have got a level of support that goes beyond simply free versions, then we have Zulu Enterprise. What we do there is we do all of the backporting of bug fixes and security patches from the currently supported OpenJDK source code project into the older ones that we support. So currently we support as extended versions 6, 7, 8, 11, and 13. In terms of how long that's going to continue, Zulu 6 is going to be supported until the end of next year. As far as I know, we're the only people in the industry still supporting JDK 6. So if you need to run that, we can provide you with updates. Zulu 8, we will support until the end of 2030 currently. That may go on longer if required. And then the way that we do long-term support releases, we're following the same cadence that Oracle do, so 11, 17, and so on. We do 8 years of active support, meaning that we will backport all changes and we will provide updates on a quarterly basis, as well as any out-of-bounds updates that are required. And then for 2 years after that, we'll also provide passive support, meaning that we will not provide regular updates, but if there is a bug identified that needs fixing, we'll produce a new version for you. We also have concept of medium-term support, and the idea there is that because it's 6 releases between long-term support ones, there may be versions where you think, oh, that feature in JDK 14 is really cool, I want to use that. And so what we'll do is we'll enable you to say, okay, 15 is going to be the next medium-term support release. So you could deploy 15 into production. We'll provide you with updates until 18 months after JDK 17 comes out, giving you that 18 months to migrate from 15 to 17. Just to summarize, I think it's safe to say that JDK 14 is a great release. Lots of interesting new features, especially things like records, pattern matching of instance of, like I said, my favorite feature, NullPointerException, with better messages, and obviously some useful API changes as well, things like the foreign memory access API. It's really good to see that even after 25 years, there's still a lot of new things going into Java, and the pace of change is if anything, it's faster than it's ever been before. So I think this is great news for Java. And that brings us to the end of the presentation. So what I'll do now is I'll switch to see if anybody's asked any questions. Please feel free to ask questions. Okay, so let's see what we've got here. Should an X and Y on slide 0 be low and high? No, I'm definitely having X and Y in that. That's my example. I'm making it X and Y. I get to choose the variable names. When you use the / line continuation, how much white space gets included? Just from the left margin to the C in contains, is it shrunk to a single space? No, the / followed by a new line will be interpreted as a continuation. So whatever point you put that, so if you put space before it, then that space will be included. So it's only where you put the /, that's where the line will be continued on the next one. The incidental white space will be stripped from the following line. So if you have that lined up within your code, then that incidental white space on the left-hand side will be removed, but any space that you put on the left-hand side of the / will be included. Next question, is there a compiler flag to make the compiler warn and use the import if the type module is ambiguous? Comes up. I can see the same errors coming up for Java Lang record when we get to that. Also, when an imported package contains a class named record. I'm not quite sure I understand that question there. Hang on. Is there a compiler flag to make the compiler warn and use the import if the type module is ambiguous? Okay, I'm going to have a look at that and have a think about that one, because in the time I've got here, I don't think I'm quite understanding what's being asked. So I will have a look at that, and I will tweet an answer to that or write a short blog post to reference that one. Next question, Zulu OpenJDK Alpine Docker image doesn't have glibc that breaks some JNI-based encryption tools that we use. Adopt OpenJDK seems to have glibc on their OpenJDK Alpine images. Is there any reason why Zulu Alpine doesn't use glibc? Yes, there is a very good reason for that. We use the muscle library for that, and that's simply because that's the decision we've made in terms of our Alpine Linux. It seems to be a more popular choice in terms of making a very, very small image for the Alpine Linux. So we've just gone with using musl rather than glibc. I apologize if there's something that doesn't work with that. I'd like to know more. So please feel free to DM me on Twitter. I've left messages open. So if you want to send me a DM on Twitter, maybe we can look into why that doesn't work with musl rather than glibc. Okay, so I think that's all the questions that I've got here at the moment. And so we've been running for a while now. Okay, so just, oh, no, got another question here. As far as NUMA support, if I use a pod on Kubernetes and give the pod CPU request and 1 CPU, even though the underlying host VM has 16 cores and NUMA enabled, does it make a difference? I gotta say, I don't know the answer to that question off the top of my head. I have to have a look at that because that's quite complicated, because that would rely on the underlying Linux, the way that that handles C groups and resource allocation. So I'd have to have a dig into that to see whether that would work with the way that they've done the NUMA enabled part of the JDK. Yeah, again, I'll have a look at that, see if I can get an answer to that. Right, should this print a more helpful message in my test? Java, I thought it would tell me whether a holder or holder name is num. Okay. Okay, so somebody has just posted me a whole piece of code. Okay, I'll have to have a look at that, and again, I will post a tweet about that. I can't post because I'm looking at a very small piece of code here, and my window on that is very, very small as well. So, because you're catching a null pointer exception, yeah, I suppose that would work actually. Looking at what you say, yeah, it should, because all you're doing is getting the message from the null pointer exception. I wouldn't call toString. I think I'd call get message rather than toString on that. So that's probably the better way of doing it. Will this video recording be available to view later? Yes, we will be sending out a link to a recording of this as well as the slides so that you can look at those. Okay, interesting. Get message returns null, and that's on JDK 14. Okay, that doesn't seem quite right, but again, I'll have to have a look at that. So I'll try that later on. Any timeline on Zing Java 13 to get GA? We're not actually doing Zing for medium-term support. We're doing Zing only on long-term support. So that means Zing 8, Zing 11, and the next one will be Zing 17. That's simply because the typical deployment that we have for these things, people want long-term support rather than medium-term support. Okay, oh right, yeah, so Aurelio, who works for Oracle and is the product manager for that, says, don't forget that the better null pointer error messages are off by default. They're on by default in some later version. That may be why you're getting a null from the get message. In fact, that would explain why you're getting the null from the get message. So you need to turn them on with a command line flag. Somebody did point that out to me the other day and I should have remembered it. Thank you, Aurelio. Okay, so with that, I don't see, oh no, well, yeah, okay. I don't see any more questions. So I hope this has been a useful webinar, and thank you very much for listening.